All right, so this is the Recursion Notes file, and it's not really Recursion Notes, but I'm just going through, 8 sample questions, and you guys should open this up on your computer and attempt to do them on your own, because most of this chapter is just doing a bunch of different recursion problems. I don't know what they're going to throw at you, but I know that you need to be ready for them. These at first look really difficult, and to be honest, I think they are. But by the time we get through doing 20 or 30 of these problems, you'll look at these and go, this is easy points for the AP test, okay? So open these up and practice these with me. So given the following method, we've got a do know method with information in it. What is the output produced by the following statement? And we call the do know method and pass 3 to it. So recursion is kind of like loops. You basically call the method over and over again. So look at this. We have this 3. So M is 3 right here. 3 is stored in M. And then we run through this code. We got an int value. M is equal to 0. Is 3 equal to 0? No. So we go to else. And so then do know becomes, what we do is we say value is equal to do know of what? 3 minus 1 plus 3. So 3 minus 1 is 2. So 2 gets stored in. So 2 gets passed into here. 2 is not equal to 0. So then we've got value equals do know 2 minus 1 plus 3. And so then we've got 1. Then we've got value equals do know 1 minus 1 plus 3. So 1 minus 1 becomes 0. And so then we've got 0 is equal to 0. So then we have value is equal to 3. Okay? So then what we do, we've worked our way down what I call the stack. We've worked down the stack. Now we got to work our way back up the stack. And maybe the best way to show you this is kind of writing this out. Kind of the best way I can almost think about this and explain this is, well, right down here, let me write this out. So value is going to be set now to 3 plus 3 plus 3 plus 3, which is 12. So the final answer is 12, but let's look at how we got here. Okay, so let's see here. Okay, so this 3 gets passed back up to this whole section right here. Okay, so this is really 3 plus 3, which is 6. Okay, this 6 gets passed into here. Okay, so then we get 6 plus 3, which is 12. This whoops, it's 9. Sorry, oops. So then we get 9 right here. And so this 9 becomes this whole thing. So it gets passed back up the stack, and we have 9 plus 3 is 12. Okay, so your final answer, that's how I got that. And that's how I got 3 plus 3 plus 3 plus 3. That's really what's going on here. You go back up the stack once you're down it. So you got to go back. That's really weird, but just follow it and you'll get the right answer, okay? So this is the best way that I know how to teach this stuff, okay? So next up, we got the method what, that 5 is passed into it. So M becomes 5. So if if M is 0 or 1, then we do this, else we do this. So we have what here? We have temp is equal to what, which is 5 minus 2. and we got plus 5. So 5 minus 2 is 3. So 3 is not equal to 0 or 1, so then I have temp is equal to what? And then we got 3 minus 1. 3 minus 2. And then plus 3. We've got 1 here, and then we do temp is equal to 0 because m is now 1, right? So during this whole time, m is equal to something. So m is equal, we got to pop back up the stack and see what it prints. Now it says, what would the output be if the following statement were executed? Well, first of all, temp I guess is returned, so temp is never displayed, but the output would be m. If we go back up the stack, we have this m right here, m equals, and then it equals 1 at first, and then m equals 3, and m equals 5, okay? So that's kind of what's going on there. Let's keep going. So what does result 2 display? Okay, so what do we got here? -3, and -3 gets passed in here, so num is -3. Okay, so we have what? -3 is not greater than 20, so we have so we got -3 plus 4 plus 2 times -3. And so -3 plus 4 is 1. So then we got what? 1 plus 4 plus 2 times 1. So 1 plus 4 is 5. So then we've got negative, excuse me, 5 plus 4 plus 2 times num, which is 5. So then we got 5 plus 4 is 9. So we got 9 plus 4. And that's 9. We got 13. So then we got 17. Now notice, why am I just doing this over? Because none of these numbers right here are greater than or equal to 20. So then I got 17. I got negative 17 plus 4 plus 2 times 17. 17 plus 4 is 21. So it returns -5. Okay. Okay, so now we start needing to do what I call popping back up the stack now. So we have basically -5 is this whole section right here. Almost think about it like one of those Russian dolls with multiple layers. This goes in this Russian doll's layer right here. So you would have -5 plus 2 times 17, and that's equal to 29. Okay? Then this whole thing, which is 29, goes into this layer of the Russian doll. Okay? So then you've got 29 plus 2 times 13. And that is, what did I put down? 55. Okay, 55 is this whole thing. It goes into this Russian doll's layer. Okay, so then I have 55 plus 2 times, I'm going back up the stack, so I got 9 right here. 9, and that is equal to 73. Then I got 73 plus 2 times, what, 5? And that is 83. 83 plus 2 times, what do we got here? 1. And that is what? 86. So then, let me think here. 86. Sorry, my phone's ringing. I gotta pause it. All right, so I screwed that math up. 2 times 1 is 2, plus 83 is 85. Sorry. So then we've got 85 plus 2 times -3, and that is -6. So 85 minus 6 is 79. So that's your final answer once you were to pop back up this stack and do the math. So again, sorry about that one. I wrote that down wrong. Okay, what does the result 3 display? What do we got here? Product 1. So num is 1 at first. And then 1 is not greater than that, so that we got 1 times product. And we passing -2 times 1. And that gives us what? Gives us, I'm going to put an extra space in there because I want them all to line up. What do we get? -2 here? -2. So then we got -2 times, and I'm going to move that over there. We got product. And then we got -2 times -2. And that gives us a 4. We got, let's say, a 4. Whoops. We got a 4 times the product. So we got -2 times 4, which would be what, -8. So we got -8 times the product of -2 times 8. So that gives us what? Sorry, this is -8. Let's mess that up. So then we got what? -2 times -8 is 16. So we got 16 times product, which is -2 times 16, which gives us what? A -32. And I'm going to move these all over so everything lines up. I don't want us to get screwed up with what we're viewing. So then -2 times a -32. That would be a +64. So 64 is greater than 20, so it returns -1. Okay, and so then the same thing, we got to start popping back up this stack. So we got -32 times -1. That gives us 32. 16. So then we got 16 here times, what do we got? 16 times what, 32? That is 512. Then we got -8 times what, 512? And that is, now you might want to check my math on these. I wrote these all down, but hopefully it's right. It equals -4096. So then we go back up, we got 4 times negative 4096. And we get, do this right, negative 16,384. So then we get what? Negative 2 times negative 16,384. And we get 32,768. And then we got 1 times 32,768. And that gives us 32,768. Okay, so final answer right here, all right? All right, 5. Okay, we got what, weirdo? We passed 40 into it, so what is x? Yeah. X is what, 40? So we've got, is 40 greater than 1? Yep, so then what do? We do weirdo 40 divided by 2, which gives us 20. 20 is greater than 1, so we got weirdo 20 divided by 2, we get 10. Weirdo 10 divided by 2, we get 5. 5 divided by 2, we get 2. You get 2.5, but remember these are ints, so we chop off the decimal points, so we get 2. So we got weirdo 2 divided by 2, and we get 1. Now is 1 greater than 1? Wait. Sorry. No, it's not, so we skip it, and then we print our s.o.p, and it prints 1. Okay. 1 plus a blank, basically. Okay. So we start popping back up the stack. We print 1. We're printing x here, so it prints that 1 the first time, then it goes back up and prints 2, then 5, then 10, then 20, then 40. Okay. So this is the order it prints in. It prints up the stack, going 1, 2, not down. We went down to figure out what the base case was. The base case was 1. Then we got to go back up and print 2, 5, 10, okay? So on and so forth. All right, 6, weird dumb. All right, weirdum. So we got x is 40. So what do? We print s.o.p. And I'm just going to say it prints 40. It prints 40 first. Then it checks to see is 40 greater than 1. Yes. So what do? We do weirdum. Weirdum 40 divided by 2. So then we get x is 20. So it prints 20, and then weirdum 20 divided by 2 should be dumb. Weirdum. Then we got 10 here. So it prints 10. So we get our 5 here. So it prints 5. 5 divided by 2. And that gives us our 2. I should have put a 5 there. I don't know why I did that, but anyway. We're 2 divided by 2 is 1. So it prints 1. So this one prints 40. Because again, we're doing this first. Okay? So we print 40, 20, 10, 5, 2, and 1. So this one's backwards because this one prints first. This one does this last. So you got to understand, and that's why I'm using these tables in this format, because it's definitely funky compared to what you've seen in the past. Okay, and this one's even worse. This is about as bad as it gets. This one, but you know, I got a strategy for this one. So pay attention here. I'm gonna have to put this in. So when you see multiple layers of recursion, so this recursion calls this recursion, okay? This starts getting funky, so you want to use tables right here, okay? So we pass 36 into this this should say recursion. And let me change that. I don't want you guys freaking out and seeing that. Recursion, okay? And so when you've got, I'm not going to write these out. What I'm going to do is I'm going to say, okay, we've got this method. That's just R36, okay? Okay, so I'm going to say R36, okay? And then I'm going to put, this is where I use my table here, okay? So in this table, is 36 less than that? No. So then what we have here is we have an R, and then we have an R, and then we have 36 divided by 3. Okay? And so I'm going to break this off to my first one out here, okay? And this one right here is, what's 36 divided by 3? It's R12. Okay, so this is just this one right here, okay? Just this inner one right here. So I'll put like that. So that's R12, okay? So R12, is that less than 10? No, so what do we have to do? We have to do this thing right here. So we have an R, and then an R, and then 12 divided by 3, and then the inner part here, this part right here, 12 divided by 3 is 4. That's going to split off into this little table right here. So we have R4, okay? Now, is 4 less than or equal to 10? Yes, so we have 4 times 2, and that is 8. So then what happens is 8 is this whole base case right here, okay? So then what we do is we do another table down here, and we have R8, okay? Because it's this base case right here becomes R, and then this whole thing is 8. So then is 8 less than or equal to 10? Yes, so you get 8 times 2 is 16, okay? Now, 16 becomes this whole base case right here for this one. So we break this down, and we have R, well, here, let me, because I like to keep everything at like basically the same level. So I'll break this down, and then we've got R16, okay? And when we do this one, we've got R16 divided by 3. Okay, and then here, 16. Okay, and then when we break this down, 16 divided by 3 gives me my R 5. Okay, so 5 is less than or equal to 10, so I got 5 times 2, and that is 10. Okay, this 10 gets shoved back up into here, which is this base case right there. So that brings us down to R10. And so then we got 10 times 2, that is 20. Okay, so after all this gets worked out, our final answer is 20. Okay, we will have a bunch of these, but see how I work through this. I work left and down and left to, and then I got to go back up, and then whatever the answer is here, up here, gets pushed down to there. And then I go back up to there, and then it pushes down there, and then here, and then back up, and then there for my final answer of 20. Okay? So when you first see this, the first 6 I went through, those are easy versions of recursion. This is probably more like what you're going to see on the AP test. But if you use these table type ways to solve these things, it's not hard, and I'll do a bunch more and practice a bunch more with you, okay? So that's that one. But that was your first taste of it, okay, of a difficult problem. And these are difficult. The last one's difficult too because they're strings, but this gives you good practice with strings, okay? So we've got a print string method that passes AP Computer Science, and that gets stored in str. So this becomes AP Computer Science. So the length of this is 19. That gets right there. Is 19 greater than 1? Yes. So temp becomes what? Temp becomes string temp equals str dot substring. Basically 0 to length minus 3 is 16. Okay, so I'm just going to put this right here. Length is 19, but 19 minus 3 is 16. Okay. So temp is then what? AP Computer Sci. Okay. And then it prints temp. Or it calls that, I guess. And so then our new string is AP Computer Sci, which is got a length of 16. Okay, so then we got what? String temp is equal to str dot substring 0 to 13 this time. Okay, which would set our temp to AP Computer S. Okay, 0 through 13. So, you know, and maybe right here you put in your index positions. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, so you can see we're 16. This is really minus 1, so there's our AP Computer Sci for this one. Yeah, it's going to do the whole thing. Anyway, and 13 is really minus 1, which is 12, so AP Computer S. So then we print string our temp. So AP Computer S, which has got a length of 13. So dot substring 0, 10. So 10 would bring us to this R minus 1 would be what? AP Compute. And again, this is difficult if you're trying to do this. It's impossible, I think, to do in your head. Okay, but if you just do it like I'm showing you and work your way down the stack and write it out, should be pretty easy. So this is 10. So string temp is equal to str dot substring 0,7. 0,7 is what temp is set to. AP comp. Then we print the string temp. So AP comp, and we've got, this is length of 7, so temp is set to APC what we got here. This brings us to 4. And 4 gives us what AP, sorry, this would be 1, and 1 would be just A. Sorry, I forgot to subtract the, oh crap. I didn't write this down properly up here. What did I miss? Temp is AP comp. I forgot to do this one right here. Anyway, well, I think I was doing on the wrong one, but string temp that gives us the APC. Let me see here. And then our final one is A. All right, so we do our print string. Okay, so then this has got a length of 1. Is 1 greater than 1? No. So the output prints this A first, right? Because we got to go back up the stack. So A, then APC, AP comp, ut, AP computer S, AP computer sci, AP computer, nope. Yep, there you go. It doesn't print the full AP computer science, okay? That's what the original string was. But we remember we subtract 3 from it the first time and then print it. So this is the last one it prints. Woo, that's a lot. So anyway, practice these on your own. Like always, watch the videos. I've got the answers for you. But you will have to definitely practice this stuff in order to understand it. So this video is done.